Hello, everybody, and welcome. My name is Tiberiu Radu. I'm a program manager on the Azure Stack team. I'm joined today by Walter, Jeffrey, and Charlie, and together we will go through the first work from home workshop, if you want, talking about running AKS Engine on Azure Stack Hub. While the session goes on, please drop any questions you might have on the Q&A box, and we will get those sorted. And with that, Walter, you should share and take it from here.
Thank you, Divi. Appreciate it. Let me share my screen. Hello, everyone. My name is Walter Oliver. I'm a program manager in the Azure Stack Hub team, and I really appreciate you taking the time to join for this work from home workshop that we put together. We're going to be talking about the basics of running Kubernetes on Azure Stack Hub. The idea is that you're going to walk out of this presentation knowing what are the tools that you need to do so, what are the prerequisites, and how you actually take advantage of these tools, and why these tools are native to Azure Stack Hub. I mean, what makes it so attractive to the platform, and why we focus so much into that. So why don't we jump into this and start looking into the various aspects of it. The very first thing is obviously this is the tool that we're going to be talking about, AKS Engine. We're going to be diving deep into this one. It's a shared tool. It's a command line tool. It's shared with the Azure team. It's an open source tool. You can go to GitHub, look up AKS Engine, and you will find it, and you'll see that it works for both for Azure and for Azure Stack. The AKS service itself in Azure takes advantage of this tool in various ways in doing some of the work that it does. So it's derived from this tool. You can think of this as the beginning of everything in regards to Kubernetes on Azure and then in Azure Stack Hub as well. You can also use other tools like our partner OpenShift, Red Hat OpenShift. There is an ARM template that we made public, and you can take advantage of that ARM template. You guys probably know what ARM is. It stands for Azure Resource Manager, and that template is available, and it will deploy OpenShift on Azure Stack. And you can use some of the open source tools available, like kubeadmin or kubespray. You can probably look into Rancher. I never tried Rancher before, but so all of these tools are something that you can. They're open source. They're supposed to work in just about anywhere you go. The only thing about OpenShift, kubeadmin, kubespray is that they're not using the native capabilities of the platform in the same way that AKS Engine does. And so we're going to look into the details of what that means in a second. So why don't we dive into the demos? Let's take a look at what it means to run one of these clusters. So let's see, for example, let's take a look at here one. All right. So here we have, this is the portal for Azure Stack Hub. These are all the different clusters that I had deployed in my subscription. If you look at any one of these, what this means is that the cluster is all deployed within a single resource group. So if we open up any one of these guys, you're going to see all the different artifacts that get created whenever you create one of these resource groups. The availability sets, all the different disks and VMs and load balancers and NICs and so forth, and the VMs themselves. This one, for example, has 1, 2, 3, 4, 5 different worker nodes and 3 master nodes that are running. We're going to look into some details on how these actually are created. But the good thing that the main thing that you need to know about it is that you really don't need to know much about this. AKS Engine creates the whole resource group for you. It creates all the artifacts for you. You don't have to worry about any of these pieces on how actually they are created. We're going to look into those details right now, so that just so you can gain the knowledge. But once you deploy these things, you don't really need to worry about them much. They are deployed onto a VNet, which is also created by AKS Engine. If you want to provide your own virtual network, you can do so as well. Sometimes some folks want to create a virtual network of their own and have them the virtual network connected to a VPN, for example, you can do so and select particular IPs, CIDR ranges, and so forth. You can go ahead and do that and tell AKS Engine that you are doing that, and you will do that in a file that I'll show in a second. So why don't we take a look at some of the things. So you look at one of those clusters, how it looks like, and if we look at this is connected to the same cluster. And normally you use a tool called kubectl to do your interactions with your clusters, and we're not doing anything different than anybody else in the industry. You can use exactly the same tools to interact with this. In this case, we're going to take a look at which cluster is available for us here. We say kubectl cluster info, and it should display exactly what we're connected to. So we're connected to the Orlando cluster, Kubernetes cluster. So now we can do commands like kubectl, say for example, get nodes. We're interacting like you would in any other occasion. So we're looking at this, what we knew already. There are 5 worker nodes, agent nodes also known. They're all Linux based, and 3 masters, for example. So that's all good. We're good. We can look into what pods are available here. Get pods, for example. All of them, what is running inside the cluster. So here it is. So we're interacting. The whole point of this is that once you get the cluster deployed in AKS Engine, you interact with it in the same exact way that you would, whether it's running on Azure or any other cloud provider, or running on premise in some other system that you may have. In here, you're looking at all the different pods that I had deployed into this particular cluster. You see that there are some things like Azure Arc. If you heard about that, we're going to touch on it very briefly. You see some applications, very, very handy applications for monitoring locally, like Prometheus and Grafana, and other items like the OMS agents down below here. This means that this thing is actually projected onto Azure Container Monitor, so I can actually monitor the cluster from there as well. So why don't we take a quick look at what those items mean? Let's move to my other screen. All right, so one way you can interact with your cluster is using some of the native tools provided by Kubernetes. So remember, we are installing a standard Kubernetes cluster. We're not doing any flavor of it. No, we're actually deploying a CNCF certified Kubernetes cluster. So for us to do that, we need to make sure that we actually pass a set of tests, and we demonstrate that to CNCF, which is the Cloud Native Compute Foundation, which is the foundation that owns Kubernetes. And we demonstrate to them that these are certified Kubernetes clusters. So that's exactly what we're deploying. And part of what we deploy is this particular tool. It's a dashboard that allows you to interact with the Kubernetes cluster. We had documented all the steps you need to enable the dashboard once you deploy a Kubernetes cluster. By the way, all of the things that we're going to be talking about here are all documented in our Azure Stack Hub documentation. So for example, this particular dashboard is handy. It shows you the various workloads available and whether they're actually running or not. So it's a way of monitoring your cluster. You can see the things that I have deployed to it. So I do have a demo set here called my Prometheus node. I have some deployments like my Grafana. And if we go down here, we see all the pods, for example. So again, we're interacting with the cluster. We're going through that endpoint provided by the cluster. And we're going to look into some details of what those endpoints are. So here are some services that I'm running, for example, and here's my Grafana and Prometheus. Prometheus is also a CNCF project. It's very handy. You can actually use for doing local monitoring of your system. It allows you to do some very cool queries onto your particular metrics that you may have. Another one that I have deployed is this my Grafana, which is a nice, handy user interface that actually works along with Prometheus very well, and it provides very nice dashboarding for you. So again, this is how what it means to run a Kubernetes cluster on Azure Stack Hub. If you had done it anywhere else, it's no different. It should not be different, right? The idea is that you are actually interacting with a standard, which is the Kubernetes cluster itself. So why don't we take a look at some of the things that happen once you deploy the Kubernetes cluster. If you happen to be using a stamp that is actually connected to the internet, then you can actually project your cluster out to Azure. And for example, a good service to use is the Azure Container Monitor. In there, you can actually see, you can project all your Kubernetes clusters and do monitoring from a single control plane on the cloud. So you can access it from multiple different places. In this case, we do have all these projects in here. Let's actually make this slightly bigger. And if you look at this guy here I'm pointing to is the Orlando Cluster WS. I'm going to be referring to Orlando all the time because that's the stamp that I'm using. And if you look in there, all the clusters are good, are running. It has 8 nodes, that's 3 masters and 5 worker nodes. They're all working the way we expect them to be. You can click on it and then see different aspects of it: node CPU utilization, memory, node count, active pod counts. You can look into the specific nodes, and the nodes will tell you whether they're running okay or not. You can see what are the processes inside those nodes, and you can see if those processes are actually working as expected. So this is a very handy tool to ensure that your cluster is working correctly, and you can actually use it for debugging, for troubleshooting as well, because you can see what processes may be having issues. Also, you can collect logs from it as well. Another thing that you can do is that you can project your clusters to Azure Arc. Azure Arc is a very nice central control plane for applying configuration and policies to your Kubernetes cluster. So again, if you have multiple Kubernetes clusters that distribute across multiple places geographically or within your organization, you can project them here and apply the same rules all across the different clusters. For example, I can go and say I want particular policies to be executed on all clusters that are projected in my subscription in this resource group, and I can do so. For example, these are examples of different policies that are being applied to this particular Kubernetes cluster. For example, if you want to make sure that all clusters have port 22 open for SSH access of the VMs, then you make that a rule, and you can apply the policy. You can also configure this to have a GitHub, a Git repo. It doesn't have to be in GitHub, but it could be in GitHub. You can have a single Git repo someplace, and from that Git repo, you can store all your configuration files. In Kubernetes terms are normally YAML files, and from there apply your configurations and some other policies from a single repo across all your different clusters. So that actually works quite well as well. So that's really, in a nutshell, on a high level, what it means to run Kubernetes clusters on Azure Stack. So why don't we go more in detail about what it means, what the tool itself that makes all these things available do, and that is the AKS Engine. So let's go ahead into the steps that it goes through when it's deploying a Kubernetes cluster. Again, you don't have to know all these details. The only thing that you really need to know is that AKS Engine exists and you can use to deploy the cluster. But let's get into it just so I can get a very good idea of it. So at the beginning, you always need an administrator, a Kubernetes cluster administrator. He has a laptop and he has a set of tools available. He uses AKS Engine to manage his Kubernetes clusters. He defines his clusters using a JSON file, which is the cluster definition file. It's also referred to, you will see me refer to it as the API model. in some of the commands that we're going to be using. But there's nothing else that JSON that specifies things like I want to use 3 masters, I want to use 3 agent nodes, and I want them to have this particular VM size and so forth. So when he executes AKS Engine, the very first thing that it does is that it creates a virtual network inside a resource group inside your subscription. And so that's the virtual network that everything is going to be based on. Again, if you specified an existing resource group with an existing virtual network, it will use that one without any problems. So once it does that, it does the subnet, and then it moves on to actually use the AKS base image to create all the VMs. So this is an important point. The AKS Engine comes along with a VHD file that you actually make, that your administrator, your Azure Stack Hub administrator makes available for you. And remember, you are, as a Kubernetes cluster admin, you're running not as an Azure Stack Hub admin, but as a tenant user of the Azure Stack Hub stamp. So at this point, you're running to a normal user subscription. You're using AKS Engine, and you're going to be creating all these artifacts inside that subscription, inside a particular resource group. Now, the VM is provided to you by the admin, and then this VM is maintained by my team. So we work with the Azure team together, and we derive this VM from the one that's used in AKS itself in Azure, and we put the bits that we need from us in there, and then we make it available through the AKS Engine to deploy your clusters. That means several things: that all the masters are created using that AKS base image, and by the way, the masters are created within availability sets. Again, AKS Engine knows what facilities are available on the Azure Stack Hub, and it can take advantage of them, and availability sets actually works quite well for that. It also creates all the agent nodes, the worker nodes, and all of those using the same AKS base image. All of those running in using availability sets. So if, for example, you have a cluster, one of the things we're making available right now as a private preview is support for Windows containers. So you could, in theory, deploy your Kubernetes cluster, and you could have a node pool set, and that's each of these little boxes here we refer to as node pools, and you can have a node pool reserved for Windows containers and the other node pool reserved for Linux containers, and so they get divided like that, and each use an availability set. And of course, things like what are the disks necessary for these VMs to exist are created by the AKS Engine along with the NICs, so that they can actually live inside the virtual network and work as we expected. It also creates things like the network security group and a routing table as well. This route table is something that is created because we have something called KubeNet, which is the network plugin that we're using to deploy the Kubernetes cluster. This KubeNet takes advantage of this table for users. In the future, we're going to be making available a new network plugin called Azure CNI, and this one in particular, Azure CNI, will not require that routing table to be available. And a couple other things that we create is an external load balancer for the masters with an external IP. What this means is that this is the IP that is the endpoint for the Kubernetes cluster. This is the IP through which all users, including the administrator, talks to interact with the cluster. Is what is known as the Kubernetes server service API, or server API, or API server, by the way, sorry, it's Kubernetes API server, the right term that is used for that. And so that's the endpoint for it. So all the other tools, like the one you saw a second ago, kubecontrol, is going to be interacting through that endpoint. Also, we create an internal load balancer, seated here on the right side, and this internal load balancer is the one that each of these worker VMs take advantage of to talk to the masters, because each of these VMs, being an agent, being a worker node of a Kubernetes cluster, they're running a component called a kubelet. And this component is the one that tells the master things like, hey, I'm up and running, I'm healthy, I'm ready for you to schedule workloads on me. So it is important that that communication happen, and we have that load balancer created underneath. Now, all of these are created for you automatically. Again, you don't have to worry. You don't even have to know that these things are happening. At the end, you're just going to end up with this IP right here, which is the endpoint for your cluster, and through that one is that you're going to be interacting. All right, so one of the last part that is done is actually deploying the Kubernetes bits on each of these VMs. And with that, we have an element called the Azure Stack Kubernetes Cloud Provider. This provider is what makes this tool native at runtime. So here's the thing. So far we talk about deployment, right? So AKS Engine knows about Azure Resource Manager. It knows all the artifacts it can use, and it takes advantage of those to create a cluster. And then it also provides the Azure Kubernetes Cloud Provider, which is a plugin inside, it's a cloud provider, it's a plugin inside Kubernetes itself that allows Kubernetes to take advantage of the platform in a native way. So this is the component that OpenShift do not have, that QAdmin or QSpread do not have, and so doing work in Kubernetes with those other tools is a little bit harder in Azure Stack Hub. This one is native. It deploys all the components following guidelines and good practices, not only for Azure Stack Hub, but also for the Kubernetes, from the Kubernetes community. So at runtime, what makes our Kubernetes clusters native is this component. It takes advantage of all the aspects that the user may, all the artifacts that the user may require. For example, the Kubernetes admin may use things like the kubectl and Helm. These are normal client tools using Kubernetes clusters, and they will be interacting through this endpoint for the cluster, and they may be requesting to do things like creating persistent volumes or doing deployment of applications, like, for example, the monitoring application that I show you. So at some point, the user is going to say, okay, I got my cluster up and running, so why don't we tell the user so that they can come along and do their work. Users come over, they are application admins or they are developers, they come over and they do their thing. One of the things that they do, obviously, is use client tools like kubectl and Helm, same thing that the administrator is using. And with those tools, they deploy their applications. For example, they may deploy an application that requires persistent volumes. So when they do so, Kubernetes asks the Azure Stack Kubernetes Cloud Provider to create the actual disks required for this to happen. And guess what? The provider goes out and creates managed disks, which are available through ARM. So that's part of what it means to be native to the platform. The users may decide that they need to expose their application using a service. That means that it needs to be accessible outside the cluster. And so for that, they say, I want a service to be created. Kubernetes interprets that and says, oh, cloud provider, please create the service. And a load balancer is created using a call to ARM, to Azure Resource Manager, and an external IP is created. All of these automatically also as well the DNS entry for the DNS name. All right, so what happened now is that you have a running cluster, right? You have all the elements up and running, you have applications working on it, user applications working on it, yet the administrator may still may have to do some operations. For example, at some point they may need to scale the cluster or upgrade the cluster because there might be a need for it. So, for example, imagine that there is a vulnerability that come up in Ubuntu, right? And so we, as the Azure Stack Hub team, create a new AKS-based image for you guys to download into your stamps and make available to the Kubernetes cluster admin so that he can run AKS Engine with that new image and upgrade the entire cluster. That's something that can happen, and it happens while the workloads are still running and they are unaffected. AKS Engine knows how to do this rollout of upgrades of Kubernetes clusters. It follows best practices guidelines and also knows everything about ARM and Azure Resource Manager to take advantage of it. So it's using the AKS-based image. And same work for scale. At some point, you may need to scale your clusters to something bigger because you have a demand, a higher demand for more resources given your users' applications. Or it may be that you need to scale down. So you realize that you are allocating more VMs than you actually need to for your workloads. So you can actually use those commands, the command scale down, scale to lower the number of nodes available. All right, so now we can look into what it means to actually deploy a Kubernetes cluster. We're going to use the AKS Engine Deploy command for that. And let's run and do that. Let me show you quickly here. Okay, so by the way, you notice, just highlight something. You notice some of the elements that are in the deploy command line. By the way, this is the command line AKS Engine Deploy. So one element is location, Orlando, meaning you need to have a stamp, and this stamp is actually has a location described as Orlando. You need an API model. This is the cluster definition file that we're talking about, and I'll show you in a second what it means to actually have this file and how you can get it and how you modify it. You need a resource group where to deploy this, the cluster 00 in this case. The resource group could be something that does not exist and the tool will create, or something that already exists and the cluster is going to be created inside that resource group. The output directory where the new API model file is going to be created. In other words, the new cluster definition file will be created because AKS Engine will be adding a set of default plus certificate information into it. And a service principal, so client ID and client secrets. So you probably are familiarized with service principal. These are identities, just like mine. When I interact with Azure Stack Hub, these are identities, but they're normally assigned to applications so that those applications can interact with the environment. In this case, AKS Engine is that to interact with ARM. And so that particular service principal is associated to this subscription. So the subscription, you need to make sure that you give rights to that service principal to access that subscription. So as a contributor role, you say, I want this particular service principal to have access to this, to the subscription. And then this last command that says Azure Stack Cloud, which basically is telling AKS Engine, please do not deploy this on Azure, deploy it on Azure Stack. Remember, it's a shared tool, the same bits run on both places. So looking at that, if there is an easier way of using the tool, and it's what we call the marketplace item, the Kubernetes marketplace item, and you find it here. You select compute, you scroll, it's right there, Kubernetes cluster. And what this template is just an ARM template, nothing more than that. What it does is that it allows you to create your Kubernetes cluster by running AKS Engine behind the scenes. So if I provide here a resource group and say Orlando, say OK, they come over, and I'm not going to fill this up. I'm going to go to the command line, but I wanted to show you these are the same parameters that you will fill up either in the command line that I showed you a second ago, or within the cluster definition file, the JSON file. You fill this up, you say OK. One step later, you create the cluster. I'm not going to do this. This particular item is not supported for production. The main reason is because it creates a Kubernetes cluster. I'm going to show you in a second how it looks like. It creates a Kubernetes cluster through an extra VM. Here's a cluster. It's a sample cluster created through that tool. If you look at the items in it, you will see a VM called VMD. So this VM gets created inside that resource group with the access to the same VNet, and in it installs AKS Engine, grabs the parameters that were passed in the particular template that you fill up, and deploys the cluster from there. Since it's doing it from here, it may run into an issue. For example, you have a bad SSH, or you had a bad service principal, which is quite common. And if you run into an issue, then the error is going to be there. It's not going to be available via the ARM feedback. And so you will miss that. And if it doesn't work, you will only see that it did not work, that the ARM template failed. You will have to then dig in and find out what was the problem by looking at logs. So it's not an easy experience. It becomes quite hard. So so if it works, it's great. And so I would recommend this as the initial tool for you to test this, and it works well that way. If it fails the first time, likely you have a service principal that you missed. Make sure that you have the right service principal and that you give the rights to your subscription and just run it, and that's basically it. So why don't we go ahead and actually go back to our presentation. We're gonna run this demo, this same thing that you're looking at here, this particular command line. We're going to do that in this VM. So I have this VM. I have no AKS Engine in this VM. Just test that. Yes, it's not there. So we need to start by installing it. And how do you do that? Well, we use the documentation. And in the documentation, we're going to just copy the commands provided there. So copy. This is the installs the script needed to deploy Kubernetes cluster to deploy AKS Engine. And we're going to do that. Say paste. Say OK. Okay, so that's the tool. We're going to install version 0.43.1 of the AKS Engine. Say enter, and this will install AKS Engine. If it's AKS Engine version, it should tell me yes, it's there. So it's actually working. So why don't we go ahead and download the file that we need to define our Kubernetes cluster. So let's go back here and we look for the deploy cluster document, and in it, the very first thing that I tell you is to grab that file. And so let's just copy that, come over and paste it. So we're downloading the file now. If we say ls, the file is right there, Kubernetes Azure Stack.json. So that's what we're looking for. Why don't we go ahead and edit that file? By the way, guys, this is the same thing that you will have in your laptop. You may actually be doing this in your laptop. You started from not having any tool, and now you're going to have the tools you need, and then you're going to execute the command to create the cluster from here. So let's go ahead and edit this cluster definition file that we call Kubernetes-Azure Stack. We also refer to it as API models, a nano. We will edit this. So the documentation will tell you what pieces to change. The very first thing that you're going to want to look for is this custom cloud profile. In there, you're going to specify the portal URL. And so we're going to be using the stamp based on that we call Orlando. So let's grab that and we'll paste it in here. There, that's the portal. From here, we're going to derive what's the endpoint, what's the ARM endpoint, the Azure Resource Manager endpoint to make all the calls. Then we go on down, and we're going to use the DNS prefix. In here, I like to use the name of the resource group I'm going to be deploying the cluster to. And for that one, we're going to use this name called Orlando-test00. How many masters do we want to deploy? I'm going to reduce that to only one, just because we want a small cluster. We're just testing, we're just having fun. I don't want to take too much resources. I also want a single instance, a single worker node. So it's going to be the minimum cluster you can possibly create, a single master and a single worker node. And now let's have the SSH key that we want to use for deploying the different VMs. And SSH is going to be the port available to access our VMs. So let's come here, add that SSH. All right, so that's it. So really there isn't anything else. You don't need to put the service principal credentials here. We're going to be using them in the command line itself. So let's save this file. All right, and now we can run the command. And let's do that. The command looks, remember the one we're looking at the slide? That's exactly the command we're going to be running, or something very, very close to that same one. Okay, here it is. AKS Engine Deploy. Location Orlando. The subscription ID that we're going to be using. The API model, that's the JSON file that describes your cluster, the one that we just edited. It's right there. The resource group we're going to be using. We want everything to come out in this output directory for anything, meaning the little files that AKS Engine creates. And the service principal that I'm going to be using, this client ID and secret, and the command that says please run this for Azure Stack Hub, not for Azure. So let's run this, and if I have everything right, it should just do his work. Otherwise, it's going to run into an issue. It will tell me what is wrong, and then I'll fix it and proceed to execute. So while this is happening, it's going to take some time. Right now, yes, now it passed the point of interpreting the JSON file. It created an ARM template and handed over that ARM template to the Azure Resource Manager. If an error comes up here, it's because ARM did not like what he saw from the tool, because I probably entered something wrong. But for now, it's working. So let's see how it is deploying this resource group. If we come here and we look at the different resource groups, we should see a new one coming up. Yeah, Orlando Test 00. And if you look in there, you start seeing all the different artifacts starting to come up, being created. All right, so that's part of what we wanted. Let's come back to the presentation and let that run for a while. See what happened if we get it by the end of the 1 hour. So the next step is doing AKS Engine Upgrade and Scale. So remember, we're all talking about the different commands that you need to manage the life cycle of clusters using AKS Engine. So once you use deploy, you will get a file that is this API model.json file that we're referring to. And that file is going to be used as an input file into any other of the other operations, like its upgrade and scale. So you want to save that file, make sure that you keep that in a safe place, because it also has some certificate information that you don't want anybody to get a hold of. So using that file on AKS Engine, you can say, I want to upgrade the cluster, I want to scale the cluster. When you upgrade the cluster, obviously the resulting API model JSON file will contain something like Kubernetes version change to 115. If that's where you change, the count number may change, and a few other defaults may change. So why don't we actually go ahead and do a demo of this? Let's do an upgrade demo. If you look at the parameters, are pretty much the same. The only one that is different in here is the upgrade version. We did not see this parameter before. And here you specify the version that you want to upgrade your cluster to. So why don't we go ahead and do an upgrade of it. So let me see. Yeah, I think we're going to be using this other VM for that. Yes, that one is. Why don't we take a look at the version of the cluster available here. If we say kubectl version. All right, so this cluster is running version 1.16.1. Okay, so we need to upgrade from that one up. Now, which version can I upgrade to? Well, for that, we can ask AKS Engine, AKS Engine, get versions. So if we look for 1.16.1, it's right here, and it allows me to upgrade to 1.16.2. All right, so we need to run that upgrade command that you saw a second ago, but we need to use the 1.16.2 version number in it. So why don't we do that? Okay. Okay, but before we actually do that, why don't we see the name of the cluster that this is connected to? Just make sure that we're using the right cluster. So we'll say cluster info. And I'm hoping that this is cluster 00. Yes, Orlando cluster 00. Perfect. So we are in the right place. Now, with that information, we can come over and I'll bring over the command line. We'll take a quick look at it before we run it. All right. Okay, so here is AKS Engine Upgrade. Same command line we're looking at the slide before. Orlando, the subscription ID, the API model we're going to be using is stored in that particular directory. The resource group is Orlando cluster 00, RG, upgrade version 1.16.2. That's we determined that by looking at the versions that AKS Engine can upgrade 1.16.12. So, by the way, just to clarify, this upgrade command is actually quite powerful. You could also imagine that if you have a hotfix and you get a brand new VHD image from us with that hotfix in there, whether it's fixing a problem, a bug, or is a vulnerability in any Ubuntu or anything like that, we provide the patch in there in the new AKS-based image. You come over here and you run the command. You don't have to increase the upgrade version for that at that point, but you need to force, you use one of the options parameters is -- force. You force the upgrade, and so it will grab the image that we provided you, and it will patch your cluster with that image. All right, so let's go ahead and run this. Now it's going to be, yep, this is starting to do the work. It will go through the entire cluster. It will look at the different masters. You see, okay, there are this many masters, and it will grab one master. It will cordon the master, it will drain the master, and then it will replace the master with a brand new VM with a new image in it. And it will do that across all the cluster. It will do so if quite nice, elegant way. But it's doing one machine at a time. It won't affect your users' workloads. So actually that works quite well. All right, so while this is doing his work, why don't we go ahead and do a scale? All right, so we'll come back here. We're looking at this before. Let's clear the screen a little bit because it's too, and let's take a look at the command for doing scales. So here's the slide. This is the command we're going to be running. As you can tell, same type of parameters, pretty much the same type of information. The only thing that is different here are two things. One is the new node count. In this case, we're going to change the Kubernetes cluster to a different number of machines, and we're going to deploy with that extra number of machines, or we're going to decrease the number, the machines. And we're going to provide also what we call the master FQDM, which in reality should be called the Kubernetes server API, right? Because it's the endpoint to the API. So we're going to be running this. It's similar command to that one. But before we do that, let's take a look at this. I believe this one had five kubectl get nodes, 5 nodes, 5 worker nodes. So let's find out. It has, yeah, 5. So we can change this to 6. We can run the command with 6, and let's do that. All right, so let's take a quick look at the parameters before we run it. All right, so same parameters you saw before. The new node count is going to be 6. So it's going to increase the number of agents to 1. It does not increase the number of masters. Once you deploy your Kubernetes cluster with a particular number of masters, it will remain at that. The AKS Engine tool will not change that. All right, so let's go ahead and run this command so that the scale process starts happening. All right. All right, so while right now it's interpreting the JSON file that it knows it found right there, and from there it's starting to do the work. It's going to take some time for ARM to come back and say I'm done with that. All right, so while this is happening, let's come back and take a look at the deployment process. Is still going. I was hoping that was going to be done by now, but it's not. It's okay. And we have, let's see, resource group, Orlando test. This is the one that we're looking at. Yeah, it has already 14 items created. It may be close to finish, but it's not quite there. That's fine. All right. So why don't we, let's review the state of these other guys. So the upgrade is still going on. It's doing his work. That's all. Everything is healthy. So these are operations that take some time. We're talking about Kubernetes clusters, multiple VMs to be affected. They all definitely take some time. So one thing that you can do as well. So right now you saw me deploying, executing AKS Engine directly on the command line from my laptop, right? Well, sometimes you want to automate that. Sometimes you want to be able to deploy these things and do deployment of AKS Engine Deploy, AKS Engine Upgrade, AKS Engine Scale, and other type of activities in an automated way. So you can actually do those things right now through something like Azure Pipeline. So why don't we actually take a quick look at that? Let's see, it's here. So for example, here is a pipeline that I created, and it simply points to a particular script that says cluster deploy.sh. And guess what is inside that script? It's nothing more than the AKS Engine Deploy command. And so from here, from this central place in the cloud, I can deploy in different clusters across my different data centers that I have access to, so it allows me to do all my testing quite easily. I can do scales and upgrades through the pipelines available. So let's take a look at the pipelines for a second. So I have pipelines here. Okay, so I have one for deploy, one for scale, one for upgrade, for example. I just wanted to show you that. And notice that this Kubernetes cluster was created. So why don't we go and take a quick look at how that looks like. The cluster should be right here. Refresh. The resource group. Here's the cluster that we created. Why don't we actually connect to the master, to the endpoint for the cluster itself, and cluster type, group by type. Here the master, remember, it was a single master and a single agent. And let's grab the public IP. One of the cool things that we do is that we actually install kubectl inside the master. So we can actually grab this, connect to it. Let's connect to it through this same tool that I got here, which is quite handy. And Azure user. And the public key that we've been using for all these guys. We'll connect to it. Great. Oh, nicer font, bigger, good. All right, so if you say kubectl cluster info. And there it is, Orlando test 00. So this is what we wanted to see, right? So if you say kubectl get nodes -a, show me everything should be running right now. Okay, nodes, everything should be ready. Sorry, these are the actually nodes I was thinking of pods, no nodes when I talk, pods. And I expect to see all the pods in running state. Nothing is broken. So far, it looks like a healthy cluster. So realize that we took this VM that had nothing in it. We deployed AKS Engine to it. We downloaded the JSON file. We modified the JSON file, and we run AKS Engine to deploy the cluster. And we are now connecting to that cluster and seeing it running and healthy. So having said this actually completes the technical presentation. Now we can look into your questions.
So the first one was if you can deploy these Kubernetes clusters in already existing resource groups. Do you?
Yes. Mm-hmm. Okay. So the answer is yes. In fact, you can deploy the Kubernetes cluster into a resource group with an existing VNet. So you can plan your virtual networks ahead of time. You may decide that you want particular ranges on your IPs, and so for that, obviously, your VNet needs to live inside a particular resource group, and you can then modify the JSON file to include the VNet you want to deploy to. And in the command line, just that same place where you specify the resource group, you will be adding that existing resource group.
The second question was if there's a way to use scale sets when deploying these clusters.
Yes, but it won't work. So we have some issues, some bugs that we need to go through on scale sets with VM scale sets. As soon as we get through those, we will make those available to AKS Engine and at least let you guys know that it is working. But right now it's not. Right now it's using availability sets only.
The next question would be around using AKS Engine on Azure Stack with support of external storage. That would be for stateful containers.
So you can plug in storage plugins like any other Kubernetes cluster. When we talk about external storage, that implies Azure Stack Hub allowing external storage to be plugged into it, and that's something that our team is actually looking into separately. So once that functionality is available, we can play with providers plugins and see how that works. At this moment, we haven't tested any of that, no.
But any network storage, if it's accessible from the container itself, that would work, right?
Yes, if it is accessible within the container. Well, so we just have the provider, the Kubernetes provider that we have uses our Azure native storage. You will have to bring in a new storage provider, a new plugin, one of the ones available out there, or the one that the particular vendor provides to plug that in. Now, we haven't tested any of that. In the moment that we start allowing vendors to bring in new storages and attach them to Azure Stack, and these storages are container-based storages and they have Kubernetes plugins, we can test those and we can say for certain their status, right?
Okay.
But at this moment, we haven't done so.
Makes sense. Can a customer bring their own container images?
Container images, yes. Obviously, yes. You can deploy your own container images. You can store them in, say, for example, Azure Container Registry and deploy from there. That assumes that your stamp is connected. And but if it's not connected, you can set up your own container registry. And Charlie has some nice templates available in the one of our open source GitHub repos, and you could use those, or you can use Docker, for example, or any one of the other container registries available locally, and then deploy from there.
Excellent. And on this point, you've also mentioned the disconnected. Are there any specific things that a disconnected scenario should watch for?
Yes, so for both, for connected and disconnected, you need to make sure you have the AKS base image in the environment. That's something that your administrator makes available. The fact that you have it, that they download it, if it's a disconnected stamp, they're gonna download it, and we have a process to import that into the Azure Stack Hub marketplace itself. And the administrator is the one that knows how to do those things and follow those instructions. You need to ask him to make it available. And once it's available, you can do all your deployments locally. Obviously, for your containers, those containers have to be available locally. Your images for the containers have to be available locally.
Excellent. How many masters, infra, and worker nodes are deployed in a typical cluster, and what is the minimum requirement?
Yeah, so the minimum is one master and one agent node. Obviously, that works only for testing. You won't be able to do much with that in terms of operations because it's not a highly available cluster at all. Typically, you probably are going to have 3 masters, not much more than that, probably 5 at some point if you are very concerned or you're seeing some issues and you feel more comfortable with 5. But the 3 masters are normally good. Then in terms of sizes of the cluster, we're seeing all over the place. So we're seeing customers who are doing just a few of them, 5 up to 10, and we have a couple of customers who are doing up to 50, and we recommend not to go beyond 50. The reason being is because the ARM has some threshold limits on to how many calls it can take within a minute, and if you have too many nodes, then you can have too many kubelets inside every single one of these nodes. Kubelets are the different the Kubernetes components that live inside each of the agents, and they are going to be calling masters to say things to it. And when it's calling it, there is a call to ARM in between to get information about the environment that is running into, the VM that is running into when it provides that status. And that in itself potentially constitute too many calls for ARM, and so we recommend not to go beyond 50. You could try to go beyond that, but we don't recommend that. It is truly not a supported scenario at that point.
Excellent. The next question would be on sort of scaling out these clusters to public AKS. Is there an option or a pattern to do this?
No. So I understand that it has come up in the past where folks want to be able to add new nodes to your cluster, but those nodes do not live inside Azure Stack itself, but they live someplace else. Say, for example, they live on Azure. So adding new nodes that are not within Azure Stack, are not within the VNet that we provide, that's not supported within our environment. However, you could have a cluster in Azure, and and you can set up a network traffic load balancer, and whenever you reach a threshold, you can enable that second cluster in Azure. And so yes, you could take advantage of a Kubernetes cluster in Azure and make it available as load goes up. It's just a matter of how you set up your traffic manager.
The other question would be on default rules and default configuration, especially around NSG rules. The question was, can you show the default NSG rules? I think this is part of the deployment, and each deployment could check those, right?
The network security groups. So you guys can go in detail through them. We block, we deny all inbound by default. Then we allow a few things. For example, SSH is an important one to allow. QTLS, we want to allow, make sure that everything is TLS available. And you can go through them. Things, as you can tell, if you are inside the Kubernetes cluster, say you're inside an agent or a VNet, you SSH into it, you won't be able to say, for example, use ping to ping some other VM outside the network, or ping bing.com. It won't work because it's not enabled. Things to notice whenever you deploy a Kubernetes cluster, the networking for Kubernetes itself, the pod networking that we call for Kubernetes, is not really fully reflected here because it's an abstracted network. In there, for example, whenever you deploy a pod, an application onto that cluster, it will run fine. But to get to it, you need to expose it. And so Kubernetes provides the concept of creating services around your applications, and there are multiple ways you can expose those services. For example, as a load balancer that automatically creates a public IP, or you can say a node port for it, and so it's going to be available within the VNet, and you can say cluster IP exposure, and what that means is that it's exposed to other pods inside the cluster, but nothing outside. So there are multiple ways of exposing this, but the network is pretty much a private closed network itself. And this is the infrastructure NSG. Feel free to go through those in detail, and if you have particular questions, send them to us, and we'll take a look and answer back.
So one of the first questions was in the sense of the minimum slicing requirements for CPU and memory for running, let's say, a 3-master cluster with 3 worker nodes. And are there any sizing documents on this?
Yes. So we you can run a very small cluster. We recommend to start with what the default is in the JSON file that we download. So if we look at that JSON file, this is the JSON file that we were talking about before. We recommend you start with the standard D2v2 size. We have, you likely can run it with smaller than that. We have not done testing running with smaller than that. So this is what we recommend to start with. Hopefully that answers the question.
And the second one is sort of linked to this, and it's considering that the limited resources on Azure Stack Hub, are there any guidelines or limitations or like a safety limit to make sure that Hub doesn't run out of resources when deploying Kubernetes VMs?
Yes, in that same document where that explains how to do the deployment of the cluster, when it comes down to deciding the number of agents and masters, in the part for the agents, the worker nodes, when it talks about how many of these account for this, we recommend to not go beyond 50. So the reason being is because going beyond 50 may actually generate an overload onto the Azure Resource Manager threshold. So Azure Resource Manager is a service. It has an endpoint, and it protects itself from DOS attacks, right? Denial of service attacks. And one of those things is to have some thresholds on how many requests it's willing to process. So if you have more than 50 VMs, you run the risk of actually running into that issue. Hopefully that answers the question.
Okay. Is there an AKS, is the AKS monitoring enabled by default, or does it require a post-deployment configuration?
Good question. When they're talking about AKS monitoring, they're talking about okay, let me see. I think they're talking about the Azure Container Monitor. See this screen? No, not this screen. Okay, it's this screen. One thing that I wanted to touch on a little bit more is in the prerequisites part. They are talking about. So the answer is you can specify within the JSON file that you want to have your cluster be automatically projected onto your portal in the Azure Container Monitor. Yes, we have that capability. If you don't want to do that, if you want to do it afterwards, you can also do so. You can run follow the documentation instructions that the Azure Monitor provides and deploy the agents afterwards.
Okay. One quick note: we do have a bit more, a few more questions, so we're gonna be a bit over the time. I think it's okay from our perspective, but if you want to drop off, you have the link to the feedback in the published announcements. The feedback form doesn't work right now, but hopefully it will come back up in a bit. So the next question is in the using an alternative CNI. Can that be used with AKS Engine? And as an example, there was WeaveNet given.
Yes, so yes, you can. We do not support it. If you run into issues and you call CSS, our support team, they won't be able to help you. So we do recommend that you use Kubernetes to start with. We are going to be making available also Azure CNI pretty soon. We're working on that right now, and so we're going to be running public preview later this year. And so yeah, stay tuned, and you will be able to use Azure CNI with AKS Engine.
The next question is towards using an alternative for Azure files. So this will be like an SMB share or some sort of storage which is outside of Azure Stack Hub.
Yes, you can. We do not, unfortunately, we do not have Azure files like the customer is pointing out. We have not played with substitutes. We will leave that to the architect designing that cluster and deciding what pieces will go into that. We will love to learn from your experience and what substitutes for Azure files you found that are better. And if it's something that we can incorporate into our tests, that will be great. So we'll wait for that feedback.
The next question is on etcd. Is it clustered by default if we deploy it using AKS Engine? And where is that stored? Is it in a master node disk?
Very nice, very good question. So etcd here. So this is an example of a cluster. And if you sort this by type, you will see the etcd files here someplace. Here, okay, so here, 1, 0, etcd disk, the one I'm highlighting, etcd1, etcd2, and they actually map, they're associated to a master 0, master 1, master 2. So you will have etcd, the distributed database. For those folks that don't know what etcd is, it is a distributed database and is what is used by Kubernetes to store the state of the cluster. And so, yes, it is created. It's created as part of the masters. It's not created as a cluster outside the masters. It's actually a cluster inside the masters, and is maintained from there by Kubernetes. And it's implemented via managed disks, like I showed you a second ago.
The next question is around OpenShift and running OpenShift on Azure Stack Hub, and if there is support from Red Hat for doing this.
Yes, so back in May of 2018, sorry, we announced, or should I say, Red Hat announced support for Azure Stack Hub, both using Rail and OpenShift on Azure Stack Hub. Unfortunately, this support, I don't believe, includes OpenShift 4.0. I will have to go back and check, but the 3.x versions are included. At least that's what I personally have tested myself when I own that area. So yes, I did actually work with that team, with the Red Hat team, to make that happen way back then. And yes, they support it.
The next question is a bit on the roadmap side, and it also mentions Anthos, which has an admin cluster that manages user clusters, master nodes. So it provides a model of an abstractization layer, pretty much. Do we have a roadmap towards abstracting away this master node management?
Yes, so there is the question about are we doing anything similar to Anthos, or is Anthos doing something similar to what we're doing? And yes, well, it is a competitive place. We are doing work, and what I mentioned is, during the presentation in terms of Arc, for example. That's a good place to start looking into what we're doing. Or unfortunately, we're not talking in a NDA session, so we cannot really go into details. But by looking at what is public right now, the fact that you have a central control plane where you can manage multiple different clusters. It gives you an idea that we all in the industry are providing these centralized control planes.
Okay. The next question is on using AKS Engine with an ADFS service principal. Is that possible?
Yes. So it's tested, it's possible, and that's actually required for running your Kubernetes cluster in an air-gap environment. And the way AKS Engine works is that you can deploy the cluster connected or disconnected. If you're using an AAD service principal, you have to be connected, because the AKS Engine and also the cloud provider that we have needs to be able to authenticate remotely in AAD. But if you're doing AADFS, and that AADFS is local to your data center, then you can run air-gap, and everything will work exactly the same way.
Excellent.
The only thing that would change, if you look at this file and you look at, let's see, what is you specified, the identity here, this one here, you specify here, that's the only change that you will do. You specify here ADFS, you will just type ADFS. And that's it, you save it, and it will just work.
Okay,
go ahead.
Two more questions. One is on scaling up and down. So as you deploy one single master in a cluster and then you scale it up, can you also then scale it down?
The masters? No, so the masters are not touched by AKS Engine. Once you deploy a number of masters, that AKS Engine will assume that you will stick to that same number of masters all throughout the life of the cluster. So we don't increase the number of masters, we don't decrease it. So you may want to plan ahead. Most people find that 3 or 5 masters are sufficient. I don't think we do not allow for more than that, I believe. In terms of the scale command, for AKS Engine Scale will only affect the worker nodes. And yes, it will let you increase the number of nodes that you have or decrease it.
Okay, and I think the last question is on BCDR, and if we have any sort of patterns around BCDR for running this across multiple Azure Stack Hubs.
Yeah, so very good question. It's something that we should actually make public. We should actually test a few patterns and make those public and recommend. Normally, you will have 2 different Kubernetes clusters. You probably want to have your applications to be stateless and have them connect to a central database, probably even outside the clusters themselves. That will be a very simple pattern to follow. And as long as you keep the same configuration, for example, you use something like either Azure Arc or Azure DevOps pipelines to make sure that you apply your configuration equally to your clusters and do your deployments equally, then it should just work.
Excellent. We will collect all the questions. I think we touched all of the ones in the chat. We will collect all of them, including the ones from the previous session, and sort of package these together with the slides as well as the recording and publish them somewhere next week. Till then, if you want to send me that selfie, I will make sure to create that nice group picture and have it shared as well. The feedback form apparently doesn't work right now. I don't know why, but if you want to check it in a bit, it should be up fairly soon. Thank you everyone for your time. Thank you, Walter. Thank you for staying over. We are 5-6 minutes over already. So thank you for staying with us, and have a good rest of the day, evening, night, wherever in the world you are. Thank you, Walter.
Thank you, everyone. Thank you, TV.